Hello, of you. The subject I'm going to release high voltage engineering, unit 3, generation of high voltages and currents. The introduction point of view I discussed in the last class, and coming to the generation of high DC voltage. So high DC voltages. Today's class we will discuss about DC voltages. Okay. So actually the generation of high voltage means it may be DC or AC and impulse generators also. Okay. So it requires some applications. That's why we are going to generate this high DC voltage, right? So in the high DC voltage, we have mainly in this discussion we have that is here generation of high DC voltage is mainly required in research work and purely scientific, that is nothing but applied science, applied physics also. Okay, so it requires approximately 100 to 200 kilovolts and generation of DC voltage up to 100 kilovolts. Electronic wall rectifiers are used. So today's topic is nothing but about rectifiers, right? So mainly we have two types of actually rectifiers present. So that is half wave and full wave rectifiers, right? So rectifier circuits for producing high DC voltage. So why we go for rectifier means actually the generation of power is nothing but in AC manner. You should convert that AC to DC. So as per our requirement, okay. So for the generation of DC, you need to convert the AC to DC. So that is we go for rectifier units. Okay. So rectifier circuits for producing the high DC voltages from AC sources may be one half wave and two full wave, and third one also voltage W type rectifiers. In the voltage W type rectifier also we have half wave, full wave also. Okay, so we'll discuss in that. The rectifier may be an electronic tube or a solid state device. So nowadays we are going to discuss that it may be a semiconductor device, that is SCRs. Okay, we use SCRs only. Okay, if you use a number of units in series, so then you can reduce the ripple also. Okay, so we can get the distribution, voltage distribution also. Okay, right. So this is the half wave rectifier and this is the full wave rectifier. Okay, so coming to the half wave rectifier, this is the circuit. Okay, this is the transformer. So high voltage transformer, this is the input, AC input. The AC input is converted to DC by using the rectifier. Okay, here I am using a capacitor. So capacitor, what is the need of capacitor also we are going to discuss here. Okay, first of all, you know that about rectifier, that is half wave and full wave rectifiers. Let us see a small diagram for the half wave rectifier only. So this is let's say, I need to change the color. Okay, let's say this is the sinusoidal wave, that is input wave. Okay, input wave. Okay, this is input waveform, that is V of t. Let us say this is the V of t. Let the output waveform becomes, okay. So during the during the half cycle, means during the positive half cycle, this is the positive half cycle and this is the negative half cycle, right? So during the positive half cycle means this is plus and this is minus, right? So then the current passes through this way and the rectifier will be forward bias. The rectifier will be forward bias, right? So this the diode will be forward bias and the capacitor charges up to V max. Okay, the capacitor charges up to V max. That will be appeared across the load, that is V max. Okay, right? And during the so the total supply voltage exists across the supply. So this is the positive half cycle. During the negative half cycle, so this will be changes. This will be changes, right? So this will be changes like, let us say this is the minus and this is plus. So up to at this point, let us say the current passes through this way, right? So the current passes through this way. Previous concept in opposite direction, right? If the current passes through this way, so the diode will be open circuited. Diode will be open circuited. Diode will be open circuited, right? So the diode will not conduct. That is reverse in reverse bias. So then it becomes an zero. Okay, right? This is zero, and then after that positive half cycle. Again, the positive half cycle means so again the positive cycle means this is plus and this is minus. Okay, this is plus and this is minus, so then the current passes through this way. Okay, then the rectifier will be forward bias and it should be a short circuited, right? So like this we can get the half wave rectifier waveforms, and so this is the positive half cycle again. Okay, so during the negative half cycle it will not be conducted. Okay, so coming to the v average. Okay, average output of average voltage, which is nothing but Vm by pi. Vm by pi. That is Vm nothing but V maximum. V maximum. This is the value of maximum Vm maximum value of the sorry sinusoidal wave. So this is the output. The output has the maximum value. Let us say this is the Vm. Okay. So during this about half wave rectifier, the output voltage, the average output voltage is nothing but a Vm by pi. Right. So coming to the fully rectifier, right? So in this fully rectifier, same. This is the transformer and this is the input AC. The input AC is converted to output. That is a DC. You should convert into DC as per our requirement. So through a transformer, right? So if the transformer has here, mainly actually we have actually two types of connections are there, right? So fully rectifier has two types of connections. Okay, so first one is center tapped. This is the center tapped. Actually, this is called as in fully rectifier who has two types of rectifiers. So one is centri top, centri, center tapped, center tapped rectifier, and second one is bridge rectifier. Second one is bridge rectifier, right? So first one is center tapped, second one is bridge rectifier, right? So center tapped. This is the nothing but a center tapped rectifier, right? So in the center tapped rectifier, okay. So in the earlier, actually in the earlier case, that is a half wave rectifier operates in a positive half cycle. So the average output is less than the less, but in case of full wave rectifier, it is not okay. It will be increase. Okay. So right. So coming to this one is this is nothing but a center tapped rectifier. Let us say the circuit is like this. Input voltage, okay, input voltage is like this. So let's say this is V of t. Let's say, okay, this is V of t. So what is the output? We can say that what is the output? Okay, so in this we have two diodes, that is A and B. So that is A and B. One is a center tapped, right? So this type of full wave rectifier, actually this has I told you there is center tapped and bridge rectifier, right? During the during the half cycle, I think positive half cycle. So D1 I think D1 or A rectifier, let us say rectifier A. Rectifier A will be conductor. Rectifier A will be conductor, and D2 will be that is this is, let us say this is positive, let us say this is negative, and this is positive and this is negative, right? Because so this is a positive half cycle, right? So the positive half cycle like this, so then the current passes through like this. Okay, okay, in this also the current passes through like this, but in opposite direction, right? So then the B rectifier B will be, that is a reverse bias. Okay, this is forward bias. Okay, so then the circuit point, the positive cycle circuit becomes like this. In the reverse bias, that is means reverse bias means in the negative half cycle. So during negative half cycle, D1 will be D1 nothing but diode D1, nothing but this is just a minute. Right. So during negative half cycle, D1 will be reverse bias. D1 will be reverse bias. That is rectifier A. Okay. So D2 will be conduct. D2 will be conduct. D2 become so forward bias. Yes. So this is that's why here also during negative half cycle also the voltage across the capacitor charges and which appears across the load, that is V maximum. Okay. So then the positive half cycle is same circuit, right? So during this, so this is, let us say, actually we can say that this is positive, negative, minus, and this is plus. So at this point, the current passes through this direction, right? So to average for this center tap 2 Vm by pi, nothing but a maximum value of voltage divided by pi for the center tap. Next, second one is we have bridge type of rectifier. Bridge type of rectifier, actually you know that, but in textbooks he has not given. So just chonamma osari ala undo bridge rectifier. So the diagram shown like this. It consists of four diodes. Four diodes. So this is the bridge rectifier. This is the transformer. This is single phase AC supply. AC supply. So there is a fuse and a neutral. Okay. So by using the bridge rectifier, I need to find out the same. The output cannot be changed. Okay. So there is a two-way maximum will exist, but to overcome the send tapped and not required send tapped in this connection. So same sinusoidal wave. This is input waveform. Okay, and then coming to half-wave rectifier and full rectifier. Okay, so in the half-wave rectifier only we can exist only one waveform, but like a positive half cycle and negative half cycle will be considered. So for the positive half cycle, right? In the positive half cycle, so positive half cycle ఏంటమ్మా, this is plus అనుకుందాం and this is minus అనుకుందాం. The current passes through, let's see, నేను direction మారుస్తాను, change. So the current like this passes through this way and this way. Okay, so ఈ వేలో వెళ్తుంది కరెంట్, ఇలా ఫ్లో అవుతుందా పాజిటివ్ హాఫ్ సైకిల్ పాజిటివ్ వాల్యూస్ అంటే. సో దిస్ ఇస్ యానోడ్ అండ్ దిస్ ఇస్ క్యాథోడ్ అనుకుంటే ద కరెంట్ కెనాట్ అలో, అవును ఇక్కడికి ఎలా అవ్వదు. సో కరెంట్ ఇలా వచ్చేసి నెక్స్ట్ ఏంటమ్మా ఇలా వచ్చేసి నెక్స్ట్ డైరెక్షన్ ఆఫ్ ద కరెంట్ ఇలా వచ్చేసి నెక్స్ట్ ఏంటమ్మా నెక్స్ట్ ఇలా వస్తుంది, నెక్స్ట్ ఏంటమ్మా కరెంట్ ఇలా వస్తుంది. అవునా, లెట్స్ నువ్వు అనుకోవటం దిస్ ఇస్ లెట్స్ D1 అనుకుందాం అండ్ దిస్ ఇస్ D2 అనుకుందాం అండ్ దిస్ ఇస్ D3 అనుకుందాం అండ్ దిస్ ఇస్ 3, 4 అనుకుందాం. ఓకే, 4 డయోడ్స్ D3, right? So at the positive half cycle, so diode D2 and diode D4 will be conduct, and diode D1 so and D3 will be reverse bias. D3 will be reverse bias. This is forward bias. And this is reverse bias, right? So during the positive half cycle, right, the direction I mentioned like this. Okay, the current passes through this way, and this is the open circuit, and this one open circuit and came back to the initial, right? So during the negative half cycle, let us say during the during negative half cycle, uh, so okay, sorry. Right, during the negative half cycle, so the directions I am mentioning here, this is negative and this is positive, right? So this is negative and this is positive. So then the current passes through in which way means that this is a positive, okay, and this the current is entering into this way. So the current cannot pass through this way. Oh no, it cannot flow like that. No. So then the current passes through direction. So in this way, okay, come here and come into this and the, so this is I already mentioned, this is D1 and D2 and D3 and D4, right? So then current comes this way and so in this way. So then this way and negative half cycle. So D3 and D1, D1 will be conduct, and D2 and D4 nothing but a reverse bias. That is will not conduct, reverse bias. This is forward bias and this is reverse bias. D2 and D4. D2 and D4 are reverse bias. Okay, like this the bridge rectifier also you can get. Okay, the same, the output cannot be changed. Okay, the output cannot be changed. It is 2 Vm by pi only. So V average is equal to 2 Vm by pi. So you should not mention that the diagrams. Okay, diagrams compulsory not change. Okay. So in this way, the half-wave rectifier and full-wave rectifier will be exist. In the full-wave rectifier, we have mainly two types: center-tapped, and second one is bridge rectifier. Okay. So I mentioned the same things here. So half wave and full rectifiers. These are the waveforms shown just before. The difference between these two nothing but ripple. To reduce the ripple, we go for number of units in corrected in series. Okay. And coming to next one, is voltage doubler circuits. Voltage doubler circuits. In that also we have two types. Okay. In that also we have two types of voltage doubler circuits. So I need not mention here. So directly I am going to discuss. Okay. A third one is voltage doubler circuits. Voltage doubler. Right. Coming to the circuit is like this. Let's say this is a capacitor. Let us say C1. This is diode D1, and second diode is like this, and capacitor C2. C2. This is D2. Okay, the voltage across this one is I'm going to discuss here. This is the voltage doubler circuit. Actually, in the voltage double circuit also we have two types mainly, full wave and half wave. Let us come into this one. This is phase and neutral, that is single phase is supply, right? So we have capacitors C1 and C2, D1 and D2, right? So now coming to the our voltage double rectifier, how it operates means. So let us say we have two types mainly, have positive half cycle and negative half cycle, right? So during the positive half cycle, positive half cycle, positive half cycle. So the capacitor, this is, let us say this is plus, coming to here. So this is plus and this is minus. I can say that this is positive and this is negative, right? So during this, the capacitor C1 charges and peak value of input is voltage, peak value of input voltage will be taken. Okay, na? So that is capacitor charges up to V maximum. The capacitor charges up to V maximum. Then D1 will be forward bias only. D1 will be forward bias only. So then this is the direction of the current. That is D1 will be forward bias, right? During the negative half cycle means this is negative and this is positive. So in D2 will be forward bias, right? D2 will be forward bias. This is not okay. So D2 will be forward bias. There is C2 charges up to V maximum. Right? So here already C1 have exists, that is V max, and coming to from supply, so we can get the value that is 2 into V maximum. 2 into V max. Okay, simply we can say that according to KVL, a small equation I'm going to discuss, that is Vs maximum minus so Vc1 plus Vc2 is equal to 0. Right? Vs maximum, so minus Vc1, right? So from this we can say that Vc2, we can require the output voltage at C2, right? Vc2 is equal to, so Vc1 plus Vmax, right? So then Vc1 means already we know that Vc1 already charges up to Vmax, right? So Vmax minus Vmax, sorry, plus Vmax. So then we can get the value that is V2 into Vmax, right? V2 is equal to into Vmax. Like this, we can get the value, output value, right? So coming to the half rectifier, similarly, same circuit, chinna difference. Not just this is not existing textbook, so please note down all of you. So this is D1 and this is D2. Okay. So actually, you can say that this is capacitor and this is capacitor C1 and this is C2. Actually, we can get the connections from this. Actually, I'm going to directly notice question, not like this. Yeah, I have removed that connection. So the transformer is operated like this. Okay, that D2 operates like this. So single phase AC supply. So for phase and neutral, and this is, let us say, D1 anukundam, this is D2 anukundam. The separation is same. Okay, no problem. So at the positive half cycle, D1 will be forward biased and C1 charges up to V maximum. And same coming to negative half cycle, the D2 will be forward biased and C2 charges up to V maximum. So the total voltage across the circuit becomes 2 into V maximum. This is very, very, very important. Okay. right? Like this, you can find out the voltage across the circuit's previous section half rectifier. We got only V maximum, and coming to second one, we got 2 into Vm by pi, and third section we got 2 into Vm. So that is the voltage doubler circuits. How voltage double, yeah, V max but 2 into V max, right? So that's finish our class today. We'll continue in the next class. Thank you.